Hey guys, welcome to 75-day lead code coding challenge, and today we are going to solve our next problem statement: reorder route to make all path lead to city 0. So let's start. There are n cities numbered from 0 to n minus 1 and n minus 1 road such that there is only one way to travel between two different cities. This network form a tree. Last year, the Ministry of Transport decided to orient the road in one direction because they are too narrow. Roads are represented by connection, where connection I equal to AI comma BI represent a road from city AI to city BI. This year there will be a big event in the capital, city 0, and many people want to travel to this city. Your task consists of reorienting some road such that each city can visit the city 0. Return the minimum number of edges changed. It is guaranteed that each city can reach city 0 after reorder. So we have given a graph like a structure, but this graph is a tree. It means there is no cycle. And for every city 0, 1, 2, 3, for all these city, there would be only one road to connect two cities, and there is some event that is happening on the city 0, and we need to count number of road that we need to reorient, that every from every city we are able to reach the city 0. So 0 is our source city, and we need to count the number of road that we need to reorient. So from 0 we can go to 1, but from 1 we cannot go to 0, and similarly from 1 we can go to 3, but from 3 we cannot go to 1. From 2 we can reach to 3, from 4 we can reach to 0, from 4 we can reach to 5. So number of road we need to reorient is, from first we can uh, invert from 0 to 1 road to 1 to 0. So from 1 we can reach to 0, and similarly we also need to invert from 1 to 3 road to 3 to 1, and 4 to 5 road to 5 to 4. So now when we reorient it, from every node we can reach to city 0. So number of road that we have reoriented is 1, 2 and 3, right? And similarly for second test case, from 1 we can reach to 0, from 1 we can reach to 2, 3 we can reach to 2, from 3 we can reach to 4. So number of road we need to reorient is, let's make 2 raised 2 to 1 and 4 to 3. So number of road is 2. So I hope you got the question. Now let's discuss the solution. Let's create some graph. So 0. Let's say we can go to no city 1. From city 1 we can go to city 2. Then there is a city 3. So from city 3 we can go to city 2. From 0 we can 4, from 4 we can go to city 0, and from 4 we can go to city 5. So number of road we need to reorient is, first from 0 to 1, and from 1 from 2 to 1, and then 5 to 4. So the answer is 3. Now let's discuss how we can solve this problem statement. We can solve this using the DFS approach, and let's treat this graph as an undirected graph. Do the DFS traversal road from the source route? Source route is 0. We are saying from source to target, from source to target, if the direction is positive, we can say it is a positive direction, and from source to target, if it is going inward direction, we can say it is a negative direction. So let's keep this thing in mind. We will use the sign to deflect what is the direction. It is a positive direction or it is a negative direction. So let's build a adjacency list graph for this. Adjacency list graph for this. So this is our indexes: 0, 1, 2, 3, 4, 5. This is our cities. And now a create a connected cities. Now let's build our graph. So from 0, 1 is connected, right? And from 1 to 0, it is a it is a opposite direction. So 0 to 1, it is a positive direction, but from 1 to 0 there is no road. So it is a negative direction. So negative of 0 is 0 only. So negative of 0 is 0 only. So let's say this. From 1 to 2, it is a positive direction, but from 2 to 1 there is no road, so it is a negative direction. So let's say 2 to minus 1. From 2 to 3, from 3 to 2 it is a positive direction, but from 2 to 3 it is a negative direction, so minus 3. From 4 to 0 it is a positive direction, but from 0 to 4 it is a negative direction. From 4 to 5 it is a positive direction, but from 5 to 4 it is a negative direction, right? And now we can write some logic where we are saying if direction is positive, do count plus plus. So count is a number of road that we need to invert. So if our direction is positive, we need to increase our count. So 0 to 1 is a positive direction and we need to invert it, right? And for 1 to 2 is a positive direction, but we need to invert it. And we are treating it's as an undirected graph, and we are doing the DFS traversal from the root 0. So let's now try to do the try run on this. And remember this condition, if direction is positive, we are doing count plus plus. So let initialize our count with the value of 0, and count is the number of road that we need to invert. So from 0, first we go to the road, from 0 first we go to the city 1. So now the direction is positive, right? It is a plus 1. So we do the count plus plus. So when we go to the source route, let mark it is visited. So mark it as a visited road. And from 0, when we go to the 1, we do the plus plus. So count plus plus. Now the number of road that we need to invert is 1. As you can see also, from 0 to 1, we obviously need to invert it, right? Because we need to go from 1 to 0, right? So from 0 to 1, now we reach to the city 1, mark it as an visited, right? From 1, we can go to city 0, but it is already visited because we already marked it. So from 1, we can go to 2, and now 2 is the positive direction again. So we need to increase our count. So count equal to 2. And you can see also from 1 to 2, we need to invert this road, right? Both road we need to invert. So we are able to find it also. So from 1 to 2, we reach to 2 and we mark it as a true. This city is also visited. From 2, we see minus 1, but city number 1 is already visited. So we ignore it. From 2 to minus 3, it is a negative direction and we do not need to do anything. Only for positive direction, we are increasing the count. So we reach to the city 3 and we mark it as an visited. This city is also visited, and you can see also from 3 to 2, it is a correct direction. We do not need to invert this road. From 3, we go to city 2, but city 2 is already visited. So we do not need to do anything. So now from 0, first we go to 0 to 1, then from 1 to 2 and 1 to 3. Now from 0, again we traverse to minus 4. And this is the negative direction. So we do not need to do anything. So we reach the city 4 and we mark it as visited. True. Now from 4 we can reach to city 0, but it is already visited. So from 4 we go to city 5. Now it is a positive direction. Again we need to increase our count 3. Now this city is also visited, and from 5 we go to minus 4, but this city is already visited. So our answer is 3. And you can see also from 4 to 5 we need to invert this road. So we are calculating correctly our count. So our output is 3. So I hope you got the solution. Now let's do the coding part and implement all this logic. Hey guys, let's do the coding part. So first we need to create a agency list graph. So list of integer graph equal to new array list. Now initialize our graph. Number, iterate over the number of cities, I less than n, I plus plus, and graph dot add new array list. So our adjacency list graph is initialized. Now store our positive and negative direction. Plus positive and negative direction. So iterate over your connection, I equal to 0, I less than connection dot length, I plus plus. We need to mark if it is 1 2 3. So from 1 we pointed to the 3, and from 3 we point to the minus 1. The same we have done here. So from 1 it is 2, but from 2 it is minus 1. So let's do the same thing. Graph dot add connections, comma I comma 0, graph dot get dot add connection I comma 1. So now our 1 is pointing to 3, but 3 should point to minus 1. So graph dot get, just revert this I comma 0, I comma 1 2, revert this part, and it will make a undirected graph, I comma 1 to I comma 0. We add negative for the opposite direction, and connections I comma 0. Now create your visited boolean to mark our node if it is visited or not. So boolean visited, the size of our node, the number of node. Now public static void DFS method list of integer. Take your graph as an input. What is the current city that you are currently on, and your visited boolean array. Now mark your current city as an visited. Now find all the connected city with the current city. Integer So if we are at any node for 0 or 1, we need to find the connected city. 0 is connected to 1 minus 4, 1 is connected to 0, 2. So we need to find all the connected city with the current node. So list of integer connected city equal to graph dot get all the current connected city from the current city. Now iterate over your current connected city. Integer I equal to 0, I less than your connected city dot length, I plus plus. One thing, we need to check if the city is visited or not, and we are storing it with the negative direction also. So we need to make it positive to check. So the next city is math.abl. Make it positive. Connected city dot get I. Just check if your next city is visited or not. If your next city is not visited, call the DFS again. pass your graph, your next city, and the widgeted boolean array. One more thing we need to do, we need to count, we need to take this part also. If direction is positive, we need to increase our count, the number of rows that we are inverting. So let's define a global variable static int count equal to 0, and if the current row direction is positive, increase our count. So connected city dot get I is positive greater than 0, we increase our count. So we are done. Now we can initialize our count with 0 again, call our dfs method, pass our graph. Correct. Now our source city is 0. From source city we are doing the dfs traversal and pass your boolean widgeted array, return your number count, the number of row that we need to invert, and our code is done. Now let's run the test case. We are getting some compile error, and cannot find symbol. It is a list, we need to make it size. So yeah, our test case is working. Now let's submit the solution. Our solution is also working.